Good morning, it's Mike. Welcome back to the shop. As usual, I'm saying I haven't done a lot of videos lately because I haven't done a lot of videos lately. It's just been a busy summer. But I got a kind of a cool project today, I hope. A friend of mine, I mentioned his name before. His name's Randy. He's still a machinist for a long time. He's really good, and unfortunately he's kind of ailing. So he's asked me to make a part for him. He's got I think a 2000 BMW M5, which is a whole lot of fun to drive. Anyway, it's got this is the clutch throwout arm pivot, and the plastic ones wear out. And apparently BMW used to make them out of metal for the 8 Series, but they don't make them anymore. And there are aftermarket ones, but they're about $60. So we're going to take this little piece of brass and make it into this. Let me change the camera and I'll show you why that could be a little interesting. Okay, this is so this is our part. It's pretty simple, but it's got a little bit of a challenge to it. So it's basically 10 millimeters in diameter here. It's 20 millimeters here, and then on this end we have a ball, which is the important part. This length from here to here, where this sits against the engine block, and then the arm pivots here. This is critical, so we got to get that right. And I think it's 15 or 20 mil. I think it's 20 mil. I measured it already. I don't remember offhand. I got a little drawing somewhere. Anyway, and then we've got a radius here, which isn't really critical, but we're going to try to duplicate it anyway. So that actually gives us a little bit of a taper, and that's going to be probably the hardest part. So to pull this off, this is, of course, it's German, so it's metric. Which means that some of the stuff I have isn't going to work, so we have to adapt. So I took a radius gauge, and as far as I can tell, this is about a 4 millimeter radius, which is 5/16. So I have a form tool that a guy gave me many years ago. But anyway, the nice thing is that one side's got a 312 radius, 5/16, and the other side's got a 1/4 inch. So if you hold it up to here, you can see, hopefully that shows up. I think it does. But it lines up really well. Certainly close enough, because this plastic's going to deform anyway when it's in use. So we're going to use that to form the end of it. And I took a piece of high-speed steel yesterday, and I did this ahead of time off camera, but I ground it with the same radius and about a 5 or 7 degree relief, and so it fits in here pretty nicely. So we can make our radius there, and if you hold it up to here, it turns at the right side. Yeah, is this on camera? Yeah, it is. So anyway, they line up pretty good. So I'm pretty happy with how this turned out. Just used a bench grinder, and it does have a couple little flat spots right here, but I don't care about those because it's going to be cutting up here. So I didn't worry about taking any more metal off than I had to. Anyway, we're going to make it out of a piece of brass. I don't know exactly what grade of brass it is. Bronze, I think it's brass. Anyway, it's generic. It will still almost certainly outlive the plastic part. So it'll be pretty simple. We'll turn down our minor diameter. Well, we'll turn the OD of the whole thing. Turn this down and to the right length, and then flip it around, and then we'll cut the length and then form our things. And we got a little groove in here, and I actually got to call him, but I'm pretty sure this is just for getting it out, so it's not very critical. So I'll just use a parting or grooving tool on that. Anyway, we'll move the camera into the other room where the lathe is and get started. All right, so we've got our piece of brass mounted up here in the lathe. I'm going to use the 6-jaw because it was in the machine. We're going to use this cutter because it's made for non-ferrous metal. Got a lot of negative rake, really sharp. So and it should work pretty good. So we're going to cut the small side first. This is 10 millimeters approximately. It depends where you measure it. It's about 9.85 to a little over 10. So we're going to go with 10. It's 15 millimeters long. This isn't metric, but it's 15 millimeters long. This is approximately 20. It doesn't really matter. This fits into the block, so it just needs to not be bigger than 10 millimeters. So we'll just face it off, turn our 20 mil, and then we'll turn it down to 10 mil and make it 15 millimeters long, and then we'll flip it around and make the interesting side. So this is 1-inch brass, so it's 25.4 millimeter. I'm just going to get reference size, and then I'll just punch it into the DRO, and we should be able to get down to it pretty quick. Whoop, put this in millimeters. Come on, there we are. So we're at 24.4, and there goes my phone. Okay, I don't even know where I was because my phone rang, and it was actually the gentleman I'm making this part for. So that worked out really well. But anyway, I don't know where I was. So anyway, we need to get this down to 20 mil. So we're just gonna take a quick measurement. Oh, it's in inches. Hang on a minute. So we're at 24.36. So I'm gonna punch that into the DRO. 24.36. And then we'll just get it down to 20, because this dimension is not critical. I'm going to go down to 20.5, and then we'll just take a smaller pass. And it should be about 20.5. 20.45, close enough. So we'll run it down to 20. Should be pretty close. Let's check it to see. 20.05, which is where I set the DRO, just a little hair over. So we'll take our last little pass. Again, this is not a critical dimension, but I like to hit it if I can. 20.01, we're going to call that good. So the this length is right at 15 millimeters, and this is 10. So we also need to drill a hole in the end, which is, it's nominally 4 millimeters, it's 4.03. We don't know for sure whether this is necessary. This is an injection molded part. There's a parting line on here. This was probably for the ejector pin to get it out of the mold, but because we don't know, I'm going to drill the hole anyway. It's 950 or so deep, and I don't think the depth matters at all. But it's a number, I think I got a 21 drill bit, which is fits in there nicely. So we're going to do that, and then we'll I think I'll turn the diameter and then do that. So to do that, we're going to touch off on the end and zero the DRO, and then we'll move over 15 millimeters. So the end is faced at 0. So we're going to put a witness mark at 14.5. So we know we need to go there. And then we got to turn this down to 10 mil. So we'll just make some 3mm cuts. Okay, that should be pretty close to 11mm. Check it. I've got a Mitutoyo old school type of digital mic. This is one of the micron ones that reads down to a thousandth of a mil. So we're 1097 and a little less than 1097. So again, I don't think this is really critical, but we'll get this one pretty close. Go down to 10.1 on the DRO and then measure it and then take another pass. Okay, that should be pretty close to 10.1. 10.08, so it's just slightly under. So and that's actually where the DRO is at, is 10.08. So we're going to call it good. We're just going to dial it down to 10 and go. Let it make a spring pass. We'll go over to our 15mm depth and back it out. Okay, so let's see here where we're at. It's a little bit big, 10.01 and a hair. Yeah. All right, well, it's a pretty sharp tool. We should be able to get away with this. We'll go down to where it says 999. See if we can take 1/100th of a mil. I should probably just file it, but what the heck. All right, that should do it. 10.00 and tiny bit under. Maybe let's see. Two thousandths under. Anyway, that'll work. So, and our distance should be real close to 15 mil depth, depending on how I get this lined up. 14.97, that'll do. Again, that just fits into the engine block, so really won't matter. We'll put a little chamfer on here. Okay. Now we'll just put our drill our little hole. I just keep one drill chuck with a center drill in it because it's just faster that way. So take our number 21, I think it is, drill bit, because I don't have very many metric ones. So we're gonna touch this off and then just use the tailstock wheel or scale to go in on this. About 950. So we're touching there. We'll zero this. There's 100, 200. $950. Close enough. Again, we don't even really know if this hole's necessary. I'm pretty sure it's for the ejector pin for the mold, but the original had it, so now ours has it. So we should be pretty good on that. So what we'll do is we'll just turn it around and then turn the other part to 20 mil. Yeah, move this up a little bit here. Get rid of this chuck. So we'll turn this around and then turn the rest of it down to 20 millimeter and then start forming our nose and our radius. And, I'll show you how that, hopefully we can make that come out right. I think I made this a little longer than we needed, but that's all right. So I'm trying to put it right up against the vice jaws so that I can use the jaw as a reference to get this distance, because it matters. But I have also learned the hard way over time that these jaws they don't stick out exactly all the same. They're not very different, but they're different enough so that we're going to mark the one we're using as a reference. Doesn't matter which one it is, as long as it's always the same. So we're going to use this one as a reference for getting the length. Whoops. It's definitely a lot longer than it needs to be. Actually, I probably should just part some of that off so that we don't waste as much. Maybe I can use the scrap for something. So we'll just knock some of this off with the parting tool. So our overall length after parting is a little over 3/4, so we'll just cut it off at 1 inch. That way I got a little extra. And then I still have a little scrap of brass that might be usable for something. I don't want to throw it away. So we'll just slow it down a little bit. Okay, yeah, we got a nice piece. Usable for something, maybe. Bushing, something. Who knows? I hate throwing stuff away. All right. So now we'll knock this all down to 20, and then we'll get our shoulder on there. That came out pretty good, blended really well. Doesn't matter if it's going to get turned down anyway. So our next bit, we've got this part here, this shoulder, I guess you could call it, whatever it is. Anyway, it's because it's tapered, it's kind of hard to get a good read on it, but it's just a touch over 7 millimeters. And again, it doesn't really matter, I don't think. This groove It is for a spring that holds this up against the engine block. So we definitely need it to be, you know, decently the right size. So we're going to go 7.1415, something like that. So we'll find the jaw that we marked, this one, and just lightly put the tool up against it. I'm going to set the Y to 0, and that seems to repeat, so that's good. So then we're going to move it out. There's our 7.14, and so we're going to turn it to that. So the question is how big to turn that, because if you can see, this is really tapered. Not really tapered, but it's tapered. But mostly it's just clearance for the clutch fork. So I don't think it really matters very much, but we're going to try to make it look approximately like that. So, you know, kind of measure in the middle here. We got about 10.25 millimeters. Out here it's 11. Down here towards the nose, it gets, you know, I think, as far as I can tell, it's about an 8 millimeter, you know, diameter ball, so 4 millimeter radius. So I'm going to go with 10. I'm just going to turn the whole thing to 10, and then, yeah, the taper's bigger than that on the back. So I'm not entirely sure. So maybe we'll go. Let's go. Looks like the bottom of the radius is about 11.42. So let's go 11.5, and then we'll use the form tool on it. I'm going to put the DRO in incremental mode so that I can set a 0 at our 7.14 millimeters. Okay. And I'm stopping about 1 millimeter short for the flange. So just to verify, that should be about 16 mil. Let's just check it, see where we're at. 1600, right on the money. So we're going to take that down to 11.5. This will get us to 13. And this is an approximation, so that's yeah. So that's 1 millimeter long on our flange, and we should be at 11.5, real close on this. 11.49, yep, that's real close. So we're going to take we got two things to do. So we've got our two form tools. So this one is, let me zoom in a little bit so you can see that maybe. So this tool has a 5/16 inch radius, and 5/16 and 8 millimeters are within a couple thousandths of each other. So it should be close enough. I mean, it's just a clutch pivot. So it's within a little bit, it'll be fine. So if we look at the original, it tapers up from there. And we've also got our other form tool, which you can see matches this pretty good, but it has to go in at an angle, and then I'll bring it over to do this. So that we have a radius. A file would probably work, and that's maybe what we'll do. You know, I'm going to cut the ball first, and it'll be a little smaller, and then I can use the form tool to just blend it all in. I think that will work well, and if it doesn't, well, it's on video. So we're definitely going to slow this down. So the other thing is, which I almost forgot, is we got to face this to length first, which I nearly forgot. So we'll put this tool back in, get it out of the way, go back to absolute mode on the DRO, and we know we got to come out 19.86 millimeters from here, which we'll verify this is still zero reference. And it's 0.01 mil. So that's close enough. So we come this out to 19.9. So we've got to take that much metal off of here, which we'll do. All right, well, we could get away with that one, so wouldn't do that on steel, but it works fine on this. So now we're going to put our little ball tool in, and we need to check the center height on this. I think it's right already for a 3/8 inch bit, which this is. And we are right on the money, so that's good. So this is square. So what we'll do is we're going to have it so that this just touches the end of that, and then not move it in anymore longitudinally. I'm just going to put a little blue on there so that we can see when it touches. It'll show up, yeah, it shows up. Okay, so that's just touching. I'm going to lock the carriage. Now we're just going to go straight in with the WD-40. Basically, I'm going to go in until the tool reaches center and we have a full ball. And I know that the outside will be smaller than the OD, so it's going to look funny. Happily, it's not chattering. Are we there yet? No, it's still a little flat on the end. Let's see what the diameter of our ball is. Don't want to go too small. And this tool may not cut exactly to center. 9.43. 44 either way. So if we go look on our existing one, I think we need to go a little bit smaller. So we're going to go a little more. That should have been about 4.4 millimeters, so we should be about 9 on this part of it. .08. So 6. So it's almost round in the middle. I think we're going to go another half a millimeter or so. 8.4. So that looks visually very good. So it should be about well, let's see here. We're about 8.6 and 8.6 on this one is right there. I think I'm going to call that good, and then we're going to just use the form tool to blend the rest of it in. So let's unlock the carriage, change the bit, and see where we go from here. This is very much a do it by feel kind of thing. Alright, so both of these are 3/8 bits, so that's hanging out. Let me back it up a little bit. Okay. So I purposely ground this not quite square because that's the way the existing profile is. So we're going to move the tool post a little bit to try to kind of match this up a little bit to the angle of it, the taper. And it looks kind of it moved. This is very much just a guess thing, but I think it's just clearance. That's what Randy told me. So, all right. So we're gonna just kind of feed this in until it looks about right. Because really, that's, in this case, it's pretty much about looks. Now this is a big wide tool, so it could chatter a lot. It's trying. A little more lube on there. I got to get my magnifiers so I can see when this slow it down a little more. That's almost blended. I think we'll use a file on it. And now the back of it's still got a little step, but this is still too thick too. So now if we look at the existing one, it actually leans back a little bit. So what I'm going to do is turn the tool post a little bit the other direction and see if we can't do the back and just kind of blend it all together. So we're going to go just a couple degrees this way, making real sure that it's still going to clear the chuck before we turn it on. Yeah, we're fine. So we'll just the other thing is we want to get this length, you know, about 7 millimeters, a little more, not much. I don't think it's real critical. Right now we're at now let's measure off the face that I marked, since we know they're not all the same. Depending on where the caliper lands, it's about 7.8 mil. So we got a little bit to take off. Okay, so that actually looks pretty good. Let's take another measurement here. Since it's tapered, it's just going to be approximate, but it's all it needs to be. All right, we're at like 7.13. That is going to be good enough. So let's just get this out of here. Going to hit it with a little 400 grit emery, and we're going to call this good, I think. It should be pretty good. I might use a file on that just a little. I don't know. Emery paper might be all it needs. Carefully avoiding the chuck, of course. So that looks pretty good. Looks very much like the original. Nice little taper to it. And you know, the last thing to do is we've got to put this groove in here. I have to go grind a tool. This is about, I think I measured it. It's just over 50 thousandths wide. 51, 52, something like that. 53, 52 thousandths. So I've got a piece of 1/4 inch high-speed steel that's already got an 80 thousandths one on there. So I will go grind that and I'll be right back. Okay, here's our little tool, which is very thin and actually got a little warm, but I think it'll be fine. We're only cutting brass. But it fits into our groove pretty nicely. And so, you know, it's kind of an eyeball thing on this and how far we go down and all that. Whereas got a small scale here. Whoops. As I throw it on the ground, I don't know if this will show up or not, but we'll try. So it looks like it's really just, I don't know if it might show up. Anyway, it's just shy of 100 thousandths. So that's what we're going to go, is 100. And it is basically 130 thousandths from the back end. This is what I'm gonna go with. So we'll put that into our tool holder and readjust the height. We gotta get it close to the edge because it's gonna be near the chuck jaws. I'll stick it out a little more. Try to get it pretty square in here. Okay. I'm assuming we can get it close enough. I didn't even think I can pull this out a little bit if I need to. Oh, and this isn't square because we had it moved. All right, now that's square. That is not gonna do it, so we'll slide this out of the chuck just a little. And it should still run plenty true. It's just going to hold a spring, so if it's off a little bit, that'll be all right. Okay, looks pretty good. All right. So we're going to go in here and just kind of use a scale and eyes to get the left side at about 130 thousandths. Oops, there we go. Oh. Better set our height first. It's really low. Probably about a 1/4 inch low. Well, 1/8 inch anyway. All right. We're good there. That looks pretty close. Close enough. It's just going to hold the spring. So we're going to go in 100 thousandths deep. So 200 thousandths off the OD. And we're going to do it slower. I don't know if that's even focusing. Might be. Okay. That's 100 thousandths deep. Looks very much like the original. We're going to hit this with a tiny file, I think. Just enough to take the little edge off. This is kind of a trapezoidal looking little file. It's kind of useful for stuff like this. Looks pretty good, feels good. All right, we're going to call it done. So there you go, Randy. Hope this works for you. You don't have to go out and spend $60 on another one from BMW that are back ordered from Germany. These were the machined bronze ones were on the V12 850s, and his is it's an M5. So beautiful car though. Anyway, let's see if we can show the part here. So here's our original, here's our new one. So this taper is not quite the same, but it's just for clearance. The ball looks to be really good. We got our hole, which is probably not necessary, but we have it anyway. So this dimension is good. Our flanges, the same thickness. Our grooves, it looks like I hit the 130 pretty close. I didn't measure it, but it looks like it's in about the right place. It is. Come on, slide, you thing. I missed it by about 10 thousandths, 115, 120. So plenty good for what we're going to do. So I hope this works for you, sir. And thanks to everybody for watching. Thanks for the likes. Thanks for subscribing. I always say it, but I will try to get out more soon. I do have a couple of projects to make, and hopefully the time to do them. So thanks again. Appreciate it all.